Yeah, if I have 2x minus 3y equals 12, and I'm told to graph that, there's a number of ways I can do it, but let me do that one this way to review this. I can find 2 points. I can find the intercepts is one way I could do this, the x-intercept and the y-intercept, and that quite possibly might be another question asked there. Find the intercepts. How do I find intercepts? Well, I find intercepts by setting something to 0. For the x-intercept, I set y to be 0. So if I set y to be 0, I have 2x minus 3 times 0 equals 12. And so that's 2x, that's 0, it's just 2x equals 12, isn't it? Divide by 2 and you got x equals 6. So x-intercept wise, I've got x is 6 and then the y is 0. Then on the reverse side of that, the y-intercept, we set x to be 0. And so that'll be 2 times 0 minus 3y equals 12. That's 0, so that's minus 3y equals 12. And so divide by negative 3, we have y equals negative 4. So that would be y-intercept 0, negative 4. That gets me enough there to graph it. 6, 0. It's right there. 0, negative 4. 0x, negative 4y. Be right there, wouldn't it? How about that? And it's a line. How do I know it's a line? Well, it's x to the first, y to the first, right? If you have a squared or square root in it, it's not going to be a line, but this one is a line. So we know 2 points is enough. They also might ask, what if I had, also along this problem, what if I had this? A little table. Probably will be one with a table. Fill in a table to same sort of thing, isn't it? This is just saying I've got x is 2. Find the y value that goes with it. So that would mean if x is 2, we'd have 2 times 2 minus 3y equals 12. So that would be 4 minus 3y equals 12. It's not as nice as the x-intercept ones. You have to do a little more work. Subtract the 4, so we have minus 3y equals 8. Divide by negative 3, so y is negative 8/3. Or that's negative 2 2/3, or negative 2.66666. Repeating. And then on the bottom one there, I've got y is 1. So that's just doing the same thing except doing y is 1. So that would be 2x minus 3 times 1 equals 12. So 2x minus 3 equals 12. Add the 3. 2x is 15. Divide by 2. We got x is 15 halves, which is 7.5. And those, of course, would be on the same line. Okay? All right. Now, remind you here, too, the other thing we talked about. So we've got y equals negative 3x plus 2. Well, we could do that one the same way, a table, x-intercept. But what form is this one in? Y equals mx plus b form, yeah. So I've got m is negative 3, and I've got b is 2. What's significant about those numbers? Yeah, you got the slope and the y-intercept. And so that is another way I can graph, if I put it in y equals mx plus b form, or if it's in y equals mx plus b form. It's another way we can go with it. Go to your y-intercept of 2. And then how would I use how would I use a slope? Well, slope is rise over run. And if it's negative 3, that's the same as negative 3 over 1, isn't it? So I've got a negative 3 rise, run 1, so that means down 3, and then over 1. Puts me right there at negative, 1, negative 1. That's another point, so I can graph this thing. The other graphing one that I know I probably should do example here of is the inequality. On an inequality, basically the same thing, isn't it? If I had x plus 2y is, say, greater than negative 6. That is basically the same as the ones we've just been talking about here, except what? What else is there? It's going to be a line, sure enough, but with shading. Yeah, the inequality here adds to it shading. So we got to. Yeah, it doesn't have the equal to part. It'd be the same. If it did, yeah. Remember, without the equal to part means the line's going to be dotted. Yeah. Yeah. Yeah, if you don't have the equal to part, that means you're going to have a dotted line. Yeah. Has an equal to part, and it is a solid line. Okay. So yeah, get the line here. You know, you can do your x-intercept thing. You can do the y equals mx plus b thing. I like the x-intercept thing here. Let's just do that again. The x-intercept would be negative 6. That's 0. The y-intercept would be 0 plus 2y equals negative 6. So that would be negative 3. So I have negative 6, 0 for the x-intercept and 0, negative 3 for the y-intercept. So that's going to look like this. And then 0, negative 3, just like that. And it's a dotted line. We just discussed that because it doesn't have the equal to part. And so, yeah, don't forget about the shading on it. How do I determine the shading? Check a point, not on the line. Check 0, 0 if it's not on the line. 0 for x, 0 for y. See if that's true or not. That's 0, that's 0. So 0 is greater than negative 6. That is true, isn't it? So 0, 0 works. So we shade the side with 0, 0. Here's 0, 0. So that's shading this side.